Today's presentation is an intro and overview of our newest inverter, which is the Conext XW Pro. I'm Sandra Herrera, Application Engineering of Schneider Electric Solar. So overview, introduction of our newest XW Pro. And let me give you a little history here of this platform, because this is a evolving platform which started in 2006 with our original XW, evolved to 2014 to the XW Plus, and currently with the XW Pro. However, both XW Plus and Pro are available in the market today. Okay, so I will actually tell you what are the differences between these two products and why do we have them both available in the market at the same time. Major change for the Pro is the lithium battery compatibility. One of the challenges with lithium batteries versus lead acid batteries is that their voltage doesn't move very much. They might have a 2 or 3 volt difference between 100% state of charge to maybe 20% state of charge. We learned early that just using voltage control wasn't going to be good enough, but that also applied to some lead acid batteries as well. So with the XW Pro, now we are introducing the state of charge control. We haven't taken away the voltage control, so that's there as well, but now you have the capability of selecting state of charge control. Next is the integration with some of the lithium batteries, BMS, what we call the closed loop integration. And we're doing that with our Conext's gateway. And we do that either using Modbus or CAN. And with the Conext's battery monitor, the integration of state of charge with lead acid batteries, as well as open loop lithium. So you don't necessarily need to be closed loop. You don't need to have a communication integration. The Pro will also use state of charge with the Conext's battery monitor. The next major difference between the Plus and the Pro is that with the Pro, we've changed the frequency shifting for AC coupling to be much faster. And later in the presentation, I'm going to talk about AC coupling in case you're not familiar with the concept, and I will explain what the frequency shifting does and what is the benefit. And additionally, with the Pro, we actually have a self-consumption. Self-consumption we could always do with the Plus, but now we have a combination with our gateway and external power meter where we can do even I will call it enhanced self-consumption. I will show you in a little bit exactly what I mean by this. And the grid codes. What we see in the market is many regions are asking for their own very specific grid codes. For example, California with California Rule 21, also known as 1741 SA, Puerto Rico with the PREPA grid code, Hawaii with HECO 14H. So what we are seeing is these different regions are asking for something very specific, something different. So what we are doing with the Pro now is a lot faster because it's all integrated. All you do is select on a drop-down menu using the gateway, and you can select the product out of the box without needing to update firmware, without needing to do any special steps. Out of the box, you can select from California to Puerto Rico or HECO. Okay, so where does the Pro fit? Pro was designed for residential, that's our target, and small commercial applications such as DC coupling and DC coupling grid tie. So these are customers who have net metering, for example, self-consumption, a backup, or a true off-grid. So this product continues to follow in the long-lasting tradition of our XWs to be a solid off-grid product. As well as AC coupling, I mentioned that we've made the frequency shifting faster responding in battery integrations. The Pro has a dual input, so it can manage grid and generator at the same time. You can have a customer who's connected to the grid, but because of grid instability, it already has a backup generator that he may need in case of clouds. Well, the inverter has the two connections, AC1 for grid, AC2 for generator, and it will select based on the programming. You know, one of the things that is interesting, and it was just brought up to me this morning, I was speaking to one of our product managers, not a lot of people realize the overload capability of our platform. Not all the battery-based inverters in the market have this capability. So although this inverter is a 6,800 watt continuous power at 25 degrees C or 77 Fahrenheit, it has the capability of surging up to 8,500 watts for 30 minutes in as much as 12,000 watts for 60 seconds. This is actually really handy when you have motor loads such as pumps and compressors. These loads require a high current to get started, not very long, but you also have to calculate that. So it's extremely important to know that your product is capable of this continuous, the 8,500 watts for 30 minutes, continuous power for 25 degrees C. Also has the faster transfer time in the industry at 8 millisecond. And this is when we disconnect from the grid because there's a power outage, right? So let's say we have instability in the grid. Maybe there's what we know in the industry as brownout, not necessarily completely gone, but the voltage is dropped, or we have a full power outage. And you know, the feedback I've gotten from many system owners is that they didn't even realize that they have a power outage because their appliances continued to work. There are very few things in a residential application that can detect an 8 millisecond transfer time. Also continues to have the largest battery charger in the industry at 140 amps DC. And this is actually important because what happens if we have a long extended power outage and we also have a storm? So limited solar, very no solar, but the batteries are getting low. So then the system can charge, the inverter can charge from an AC source. So a backup generator comes on and the inverter is fully capable of charging the batteries. That way the customer can continue to operate with their batteries until the sun comes back. So the product out of the box is 120-40. I mentioned it's a 6,800 watt. But it was designed in a stackable architecture. So you can actually grow the system. You can start with single inverter. For the 120-40 application, you can group as many as 4 units. I will give you a little more details of what that looks like later in the presentation. When the inverters are together, we call it stacking. One becomes the master and the other ones become the slave. And now the inverter will operate as a single larger inverter. So for example, if I have 2 of these inverters, now I have a 13.6K system with a 30-minute overload capability of 17K. So everything will double. Continuous power will double and overload will double. If you have 3, the same idea, you continue to double, which is actually interesting because not all of the battery inverters in the industry do that. Some can do continuous, but not the overload. So this is very unique to the XW platform. I mentioned that we do DC and AC coupling and also the lithium integration, which I'll dive into a little bit later. And I'm also going to give you some brand names that we're working with. So I'm not just going to talk in general terms, but I'm actually going to give you names of the batteries that we've been working with for a long time. With the introduction of the Conext's Gateway, now we have the capability of full monitoring control of the system, of the XW system, which means locally at the site, I can do all the settings, all the programming, monitor the system. I have graphs and analytics. I actually have a webinar, which I recorded, and it's on our YouTube channel if you're interested to see the capabilities of the gateway. But once we pair the gateway with our platform Insight 2, which is the monitoring and control system from Schneider Electric, now you have the same capabilities remotely. So your customer or yourselves can monitor all of your systems remotely. You know, I've been talking to some installers who've mentioned that this platform has helped them so much reduce the truck roll, the having to go visit the customer to see what's happened, because they can see all of the days, they can compare sites, and if there's any adjustments needed, they can actually do this directly from the platform, provided that they have the admin credentials. You can actually make changes from the platform, compatible with all the accessories. And later I'll mention this as well, but because it is the same dimensions, it does fit on all the power distribution panels that we've had available. So some smart energy management, which we have time of use with export power, peak load shaving, self-consumption. All of that is already integrated within the smart energy management of the product. Okay, so now let's jump to the architecture, and we're going to talk about AC and DC coupling. What is a DC coupling? Why is it called DC coupling? Let me see if I can move my mouse here and use it as a pointer. So you see I'm showing this house with my array here. Then the next thing you're noticing here, this solar charge controller. So the solar charge controller is a DC to DC device. So the array connects to a solar charge controller. This specific is our MFPT 8600. So it handles up to 600 volts on the array, which means that you will have an array between 10 to 12 modules per string. Then this device, the solar charge controller, steps down the voltage to the batteries. So in a DC couple system, the array connects to the system on the DC side. So here you have a very typical off-grid system. The array charges the batteries, and then the inverter manages to support the loads for the house. A more traditional off-grid system with a backup generator. In case of a long extended days of clouds and the array is unable to fully charge the batteries, then a generator can be used. It can be a manual generator or it can be automatic. The system can actually trigger a start command for that generator. Still DC couple, but now we have a new example of a system connected to the grid. And notice that I'm still leaving the generator there on the little block diagram. And that's because this inverter can manage both sources. And it does it with the internal logic of the inverter and how it was originally programmed. In some regions, the grid is the primary source. In other regions of the world, the generator is the primary source. And you just simply tell the inverter which is your preferred source of AC. But let's go back to the idea that this customer has just the backup generator, but his main source is the grid, and he may have a net metering agreement. He is allowed to export power out to the grid. So what happens with the power generated by the solar? So the first thing that the inverter is going to do with that power is support the backup loads. And I'm moving my mouse here so you can see what I got in the lower icon of the load panel. So that's going to be the first thing this inverter is going to do with the power. Provided that I have excess power beyond supporting these loads, then we'll go here, main powers. Typically, we leave the larger loads out in the main panel. Things such as a dryer, or if you're cooking with electric, or if there's some large air conditionings, those are typically left on the main panel. So because this customer has net metering agreement, then the excess power will continue out, support these loads, and if I still have excess power, it will be exported out to the meter. Okay, so that's how the power will flow in a net metering agreement. Now, let's say the customer is connected to the grid, second scenario, but this customer doesn't have a net metering agreement, doesn't have a bidirectional meter, so is not allowed to export power to the grid. Same scenario, inverter takes the power from the array and then supports the loads here in the backup panel. In that scenario, these loads are only supported with the grid. Okay, the inverter is connected to the grid in parallel, and all it's doing is providing current here. In this scenario with the grid present, the grid is providing the voltage and the frequency. Okay? At any time in both of these scenarios, the net metering with the export or the self-consumption where export is not allowed, in both cases, if there is a power outage, then the XW Pro seamlessly transitions to backup. And now with the batteries and the solar, it will support these loads here, right? If there was a power outage. Now I'm going to show you AC coupling. So why is it called AC coupling? So look what's happened to my block diagram here. Now you look at my house with the array, and now this is connected to a grid tie inverter. So the grid tie inverter takes the DC from the array, converts it to AC right away, and starts feeding the house. So that's the difference between DC, which is connected to a charge controller, which is a DC to DC device, to this architecture where the array is connected to a grid tie inverter, which is a DC to AC device. And this is why this architecture is called AC coupling. What happens here? This customer has net metering agreement, is connected to the grid. The grid tie inverter really does all of the work in normal conditions. And what do I mean by normal conditions? I mean that the grid is present and is qualified and available. So the grid tie inverter does its job, which is just simply inject current, is synchronized to the waveform of the grid, and is injecting current and is injecting power as much as it has. So the power generated by the array is first consumed here. If I have any excess, then it goes through the XW and out to the main panel. If I have loads here, which remember, typically here we have the big loads such as dryers, or if you're cooking with electric or things like that. And if I still have excess power here, then I will push that out to the meter. Now, who's doing all the work in this architecture at this normal condition is the grid tie inverter. Okay, so the XW Pro in this normal conditions is just simply sitting there serving as a bridge between the two panels, not really doing very much at all until we have a power outage. Okay, so the first thing that happened here, and this is again power outage, full-blown power outage, or it could be a brownout where the voltage is dropping or is unstable. The XW Pro's internal relay, it's a mechanical relay, will actually open, isolating this. We're going to call this a little microgrid. So now the functions inside the house are completely isolated from what's happening out to the grid. So there's absolutely no danger of injecting out to a grid that is having problems. Okay? So now the XW Pro is in charge of creating the sine wave. It needs to create the voltage and the frequency, and it will do that on its output. So within 8 milliseconds, the loads here in the backup load panel are already being served by the XW Pro and its batteries. This inverter, this grid tie inverter, may have disconnected. And that's because of the UL listing that requires grid tie inverters that they need to disconnect when there's instability. And this grid tie inverter may have seen the 8 millisecond transfer, which means that it will stay disconnected for 5 minutes. That's a UL requirement. It's going to start its countdown, the 300-second countdown, and is already measuring the voltage or frequency on this backup load. And once the 5-minute countdown goes to 0, it goes into its normal operations. Hey, the grid is here. I'm going to get back to work. And it's synchronized to the sine wave of the XW Pro and starts injecting current into the span. Fantastic. So if the array production is sufficient to support the loads, then the loads will be 100% supported with the array. If the array is not sufficient to support the loads, then the XW Pro will help with store energy. But what happens if I have excess power? The most common scenario of this power outage is during the day, there's no one home, there's very little consumption in the house. Nobody's home, and I have all this PV production. Where does it go? Right? So what's going to happen here is that current will continue beyond this panel because I have excess power, and it will go through the XW and back as battery charging, which it's okay because the batteries were used a little bit, so they need a little bit of battery charging. But at a certain point, the batteries are going to be full. So now I need to stop. I need to tell the grid tie inverter to stop. So here's where that fast frequency shifting that I was talking about in the very beginning comes into play. Because I don't know if you notice here, but in this architecture, the XW Pro is not in communications with this grid tie inverter. This is what makes the option of the XW Pro attractive, because I don't have to worry about this grid tie inverter needing to be a Schneider Electric grid tie inverter. It can be a different brand. So how am I going to control this inverter since I don't have a direct communication with that grid tie inverter? So we use the frequency shift. And what we do is we start shifting the frequency up from 60 hertz, because we know grid tie inverters must react to changes in frequency. They also need to react to voltage, but they also need to react to frequency up or down. But we are actually taking advantage of the frequency going up. The great thing is if you have what we call smart inverters, today's smart inverters actually react by curtailing their power as the frequency starts moving up. So what we do is that we start incrementing the frequency, the slope of the frequency in steps, so that the grid tie inverter starts curtailing this power. How do we determine when to stop? And that's all done based on what's happening to the batteries. If the battery voltage is increasing, then we know that we have too much power from the array. Once the battery voltage is stable and continuous, then we know that we have reached the balance, that what the array is supporting, what the array is delivering is exactly what the loads in the backup panel need, and we'll keep that frequency exactly at that point. I want to talk about self-consumption. So I touched a little bit on the self-consumption, but I want to talk about this new feature that we have with the XW Pro, which is called grid cell limiting. So first I'm going to tell you what we used to be able to do so that you see side by side what the difference is. So going back to my DC couple, this only works on DC couple, by the way. So going back to my example of DC couple, customer connected to the grid, whatever reason, he's not allowed to export power out to the grid. So what happens here? Let me repeat this, the power from the array out to the loads in the backup panel. Nothing to the main panel. So any load left here would have to be supported 100% with the grid. So the only loads that are going to get the renewable energy, and it's going to be here. Okay, so that's self-consumption up to now, what we could do today. Now with the XW Pro, combination with the gateway and an external meter, we can do this. Connect it to the grid, but we're not able to export power. Okay, so now we have the power from the array. First, always backup loads. Backup loads always go first. If I have any excess power, then that will go out as export. Okay, so the XW Pro will push out like it was selling out or exporting out to the grid. However, this meter here, actually what's here is a CT for the meter. CT is going to be measuring the direction of the current and preventing any current going out by sending a signal to the gateway, and then the gateway stops the export power. It doesn't stop the inverter. The inverter keeps working. All it does, it tells the inverter to not export power. In the same way as we were talking in AC coupling with curtailment, what it does is just simply, if it was exporting 20 amps and 20 amps was too much, it goes down to 15, it goes down to 10, it goes down to 5, right? So based on the information from this CT, the gateway tells the inverter to move the cell. Cell is the term that we use in our programming for exporting, to move the cell up and down. The inverter is fully functional. Even if we go to cell 0, the inverter is still fully functional. This is the first meter that we are compatible with. This is the what node. Not the only one. We are continuing to introduce new ones, but this is the first one. We have an application node, which will be, I believe is going to be posted here shortly on our website, that tells you how to connect it, how to program it, and where to connect it. This meter has a 150 amp CT, 200 and a 400 amp CT. So it isn't just for a single inverter. It could easily go all the way to big systems. So it's a great meter. So let me dive into what is this multi-unit, multi-cluster architecture looks like in a 120-240 system, starting with one inverter. Right. So this inverter is a 6,800 watt. It can overload to 8,500 watts for 30 minutes. But what if that's not good enough? What if the customer needs more power? We add a second one. In this, now we have a master and slave. They're working together. They're supporting the same loads. They're connected to the same battery bank. As a matter of fact, let's call the DC side the DC bus. So everything on the DC bus, the array, the solar charge controllers, and the batteries are all connected to this new, bigger inverter. So although you see two pieces there, once they're stacked as master and slave, they're going to behave as a single 13.6K system with the overload capability of 17K for 30 minutes. What if this customer needs more power? We can do 3. So 3 inverters, 1 master, 2 slaves for 120-240. This is a 20.4K system with a 25.5K overload for 20 minutes. Now, something funny happened to my drawing here. I don't know if you noticed what I did here. So now I'm showing you a transfer switch. Okay. You may or may not need this transfer switch with 3 units. I will give you the guidelines exactly when you make the decision, but it's basically related to the 60 amp relay, and I'll show you that relay here in a couple of slides. But with 3 units, you may or may not need the transfer switch. Okay, with the 4 units, you are making a 27.2K system with the overload capability of 34K. And the only thing that this transfer switch is doing is bypassing the internal relay of the inverter, so that we don't have to be limited by the 60 amps capability of that relay. Okay, 3-phase. Now, with the XW Pro, the 3-phase capability is coming later this year. It's not available today, although I have to say this isn't a hardware change. It's only going to be a firmware change, but it's not ready yet. But if you need to do a 12208 3-phase system, the XW Plus is available, and you can do this with the XW Plus. In a 3-phase system, what you have here is 1 inverter per phase. So you see master of phase A, master of phase B, and master of phase C. This will keep these inverters at 120 degrees. So they're 120 each, 120 volts each, and they are 120 degrees from each other. With the difference with 120-40, where the 2 phases, L1 and L2, are 180 degrees from each other, in a 3-phase, the phases are 120. And they'll stay 120 from each other because of the programming. They can connect to a grid, they can export out to a 3-phase grid, they can support 3-phase loads. What if I need more power? So then I can add a second inverter to the phase. So now what I have is a master and a slave of each phase. When they are together, they will work as either 3 or 6 units as a single unit. This is very important and actually has to do with UL listing. If there's anything wrong with one of the phases, then the whole system disconnects from the grid. Okay, so although you're seeing on my little block diagram here, these individual units, they are no longer operating as individuals. They are actually operating as a system. So in case of any issues with the grid, they can disconnect. Any of the phases have a problem, then the whole system disconnects from the grid. And lastly, capability of the XW Plus is 9 units, 1 master and 2 slaves per phase. We actually have a multi-unit guide on our website if you are interested in looking at these larger systems. By the way, this 9 system is a 61.2K continuous at 25 degrees C with the overload capability of 76.5K for 30 minutes. If you're interested on this architecture, I recommend our multi-unit guide, which is on our website. If you go under the products in XW Plus, and you will find it on, I believe it's on the application notes, you will find the multi-unit guide for design and the multi-unit concept for. So here is that 60 amp relay that I was mentioning before when we talked about that transfer switch. So what you see on my diagram here is K1 and K2 are these relays, K1 being connected to the grid and K2 connected to the generator. So these internal relays of the inverter are the ones that are 60 amp. When you parallel these relays, and that happens when you do multi-unit design, you have 1, you have 2, you have 3, you can't guarantee that the current is evenly going to split between the multiple relays. So the only way to be sure that you're going to never exceed the maximum is by making sure that the critical load panel or protected load panel, corrected my mistake there, the backup panel doesn't have any more than 60 amps or 13.6 kW continuous on the backup loads. If you have loads which can exceed 60 amps on the backup loads, right? Not on the main panel, on the backup loads, then you're going to need a transfer switch. Look what's happening here on this table on the left side. I'm moving my mouse and see if I can use it as a pointer. With 2 units, it's no chance that you're going to exceed, right? Because the rating of the inverter, so you're most likely okay to use the 2 units without a transfer switch. Once you move to 3 units, depending of how many loads you have here in the backup panel, although out to the grid, out to the main panel, and if this system is grid tie, it can export 18K. Once we start moving into 4 units, that's when I have seen that it's very likely that you're going to need a transfer switch, because even with 4 units, then the continuous out to the backup panel continues to be 13.6. So let's look at the same table, but on the right side, this is a system with the transfer switch, right? 2 units, no biggie. You don't need a transfer switch because the 2 units can handle it. But once you move out to 3 units, if your backup loads are 20.4, then you definitely need a transfer switch. And 4 units, 27.2 on the backup loads. Okay, I promised we were going to talk about lithium batteries. And I promise I'm going to give you names. I'm not just going to talk in general here. So let me cover lithium batteries a little bit here. Very important that the lithium battery that you select has a built-in BMS, because the lithium battery has to be able to monitor itself and protect itself. But with that, with the BMS, we can operate with what we call an open loop control, or a closed loop control. So let's take a look on the left side here at the open loop control. This battery is not talking or communicating with the Conect system at all. Okay. Sometimes these batteries are known in the industry as lead acid replacements. The manufacturer designed them to behave very similarly. So there's no need to have any type of control. They plug in electrically to the DC bus and there's no communication. Here, in this architecture, the battery manufacturer provides an instructional manual with settings, and during commissioning, the installer manually enters the settings into our system. On the right side, with the closed loop integration, now you see that the battery BMS has a communication cable between the BMS and the gateway. So what happens with the closed loop integration is that now the BMS tells the system what settings, what are my charging settings, what are my discharging settings. The battery now plays a role in managing what the system is doing. In addition to lithium batteries, though, with the battery monitor, we can actually monitor lead acid batteries using zero charge in the battery monitor, even a lead acid battery or an open loop lithium battery can be controlled with state of charge. And as I promised, here are our batteries that we're working with, open loop, closed loop. Some of the batteries that you see in my open loop column, we're working with them right now, and in a few months, they may be on the column on the right side. As a recap, I want to repeat some of the compatible products here. Same MPPTs, MPPT 60, MPPT 80s are compatible with the Pro. Gateway is our monitoring and control accessories such as the battery monitor, automatic generator start. All the distribution panels such as the PDP and the mini PDP are compatible because the XW Pro has the same dimensions as the Plus, and also compatible with our rapid shutdown solution. So if you need to comply to NEC 2017 690.11, 690.12, and 690.15, so rapid shutdown, arc fault, and PV disconnect, then this is our 3-in-1 solution of our MPPT Disconnect RS. Thank you for your time. I appreciate you joining us. Thank you.